My name's Ilya. The urge to email me. My email address is on there. So the agenda, the things that we'll be talking about. Some general information about fuzzing. If you've got no clue about what fuzzing is, these 2 or 3 slides will give you an introduction. Then I'll run by some of the most known and most used fuzzers, tell you what they do, some of the things they broke. Is it? Ah, thank you. Is this better? Okay. So I'll run by the most used fuzzers these days, tell you what they do, some of the stuff they broke, some additional information, and for some of those, I'll have demonstrations. That's the first part of my talk. The second part of my talk is basically about the things you need to build your own fuzzers or extend currently existing fuzzers. And then there will be a conclusion. So, general fuzzing information. Fuzzing is basically you take a chunk of semi-valid data or semi-random data and you feed it to an application. And with semi-random or semi-valid data, I mean that it's good enough so that the application thinks that it's data that it can parse. For example, if you've got a file which has a magic number and that magic number isn't there, the parser will say, oh, there's no magic number, it's not my file, I'm not going to parse it. But if that magic number is there, it'll be like, oh, this is my file, and I'll parse it, and if you're lucky, it'll break on something. So that's basically what I mean with semi-random or semi-valid data. The other thing which kind of amazes me with fuzzing is if you usually talk to people about fuzzing, the first thing that comes to mind is let's fuzz HTTP. So the thing is that HTTP has been fuzzed to death, basically. There's lots and lots of other things that you can fuzz. Basically, anything that takes any kind of input, any electronic device that takes input can be fuzzed. So some of the things that you can fuzz are network protocols, network stacks, anything that SUIT takes, arguments, standard input, environment variables, file descriptors, signals, all sorts of cool stuff. You can fuzz APIs, system calls, and I'll be talking about that later. And you can also fuzz library calls. And you can also fuzz files, and I'll also talk about that later on. The thing about fuzz is that they're amazingly cool. It's kind of hard to describe fuzzers. You really have to try some of those and see how cool it is to break stuff with doing very little. Right, so this is kind of a quick thing I made which shows you some of the things that you can use to fuzz in a SUIT binary. So, most people think of arguments and some think of environment variables, and that's about where it ends. You've got a lot of other things that you can use to fuzz. You've got signals, file descriptors, current working directory, shared memory, TTY, timers, all sorts of stuff. Right. So, the kind of fuzzers that people use. First of all, you've got manual testing, which isn't really fuzzing. It's kind of usually preparing to fuzz. What you do is you observe the data being exchanged between client and server, for example, or what a file format looks like, change a few things, run it through whatever has to parse it, and see if it will parse it or not. And you'll try to look for interesting stuff, size fields, things that might look like strings, and a few other things. Then you try to change that data and see what happens. It's usually preparation for fuzzing. But it's not uncommon that while you're doing this, you'll already find 1 or 2 bugs. The second kind of fuzzing is semi-automatic fuzzing, which is basically where you've done manual testing, and you'll have a script which does these things, and you'll do one test run of your script, and then examine what's happened. And this is interesting because you can use semi-automatic fuzzing to notice very subtle bugs, things that you would normally not find or not notice with automated fuzzing. Information leaks are a great example of that. You usually can't find it with automated fuzzing, but with semi-automatic fuzzing, those are some of the things that you should look at. And then what most of my talk will be about is automatic fuzzing. And this is basically where you have a script or a program which iterates over a very, very big loop. And this can be an endless loop, and just tries to spit out all sorts of semi-valid or semi-random data. And you just wait till something crashes or it hangs or it reboots or whatever. Right, so more specifically, the tools that you'll want to use for fuzzing. Fuzzers, they're made by people, obviously. The first one is fuzzing tools. They'll fuzz one particular protocol or one particular file or maybe something that very narrowly fuzzes one particular system call, something like that. The other one are fuzzing frameworks, and those are more interesting because they're written usually some kind of scripting languages, and they don't fuzz on themselves, but they give you very, very useful APIs to fuzz stuff. They'll do MD5 checksums and CRC32, and they can do compression and URL encoding and decoding, and all of these cool things that you no longer have to implement. So that means you get to write your fuzzers or your fuzzing scripts a lot faster than you would if you would write your own tool. Most of these fuzzing frameworks these days, they come with default scripts, and lots of those scripts are usually very cool. I mean, if it worked against one product and it's never been tested against another product, if you run against the other product, chances are you'll find a couple of bugs. Most of the frameworks are specifically focused towards network fuzzing, but there's one at least, Peach, which I'll be talking about later, which does more than just network fuzzing. It can do file fuzzing and API fuzzing and all the things I just summed up a slide ago. And the thing about these fuzzing frameworks is that, well, I mean, they've got a learning curve because you need to know the API, and if it's a language you don't know, you'll want to learn at least the basics of that language. So there's a learning curve. So, having said that, let's move on to some of the cool tools that you can use to fuzz things. The first one is Protos. This one's developed at the University of Oulu. It was initially developed in '99 until 2001, and some other people, 2002, 2003, picked it up again. And then somewhere this year, somebody picked it up again, and they developed an IPsec fuzzer, well, some of the IPsec stuff. And pretty much lots of people were vulnerable again. So this is sort of, I guess, actively ongoing. And they developed just one tool, and then which will very precisely fuzz the protocol in very deep detail. One of their most known fuzzers are the SIP fuzzers and SNMP. Unfortunately, the thing's written in Java. I'm not a big fan of Java, so, but it's still really cool. You should definitely check out their website. It's pretty awesome. Yeah, so I don't know if you could all read this, but if you read slides later, you can look over it. These are just scratching the surface. This is just some of the stuff that Protos broke. It's broken like 1,000 different things. One of the things why people might remember Protos is because I think in 2001 or 2002, they exposed what I call the big SNMP fuck up, where basically everybody who implemented SNMP based their code on some old SNMP code, and they were all vulnerable to the same bug. So that was kind of bad, and that's one of the things that Protos found. The guys who initially developed Protos started a company called Codenomicon, and they've got a whole range of fuzzers, or test suits, which is what they call it, and they're used for commercial companies. It's basically sort of the same approach as Protos, at least from what I've heard, where they go in very deep detail for every protocol and have a large set of test cases that they can run. I've been told that those products are not really cheap, so if you're not a big company, you probably cannot afford those tools. Right, so even more Protos stuff. Even today, you can use Protos against some SIP stuff, for example, and find some really neat stuff. So one of the things that a friend of mine has looked at is a Hammer Call Analyzer, which is a sniffer specifically designed for SIP interpretation. And he found a neat bug in there where you can write a 0-byte anywhere. The guy who found it is called Kokanin, which is his nickname. For those of you who might know him on something else, he's a hacker that got pH neutralized. So this is the Hammer Call Analyzer. And if you just run Protos against it, you get this. And this is the old famous pop-up in Windows saying, your program crashed, and do you want to report this to us or not? I actually don't understand all of that because this was done on a German box, and I'm pretty bad at German. But everybody should be able to recognize the pop-up window you get if stuff crashes. Right, and if you look at it with a debugger, I don't know if you can see it, but underneath there it says access violation when writing to an address. And basically you control that address. And if you look, yeah, you probably can't see it above, but it's a move instruction where you write a 0 byte to anywhere you want to. So this is a bug that got found with Protoss. And here's my 0-day giveaway for today. This is the proof of concept that Kokanin made to trigger this bug. And it's a very small Perl script, and this will exactly tell you where the bug is, and if you want to write a cool exploit for it, this is a really good starting point. Right, so moving on to the next fuzzing fuzzer. This is Smudge. It's a fuzzing framework which is written in Python by a friend of mine, Andy. Yeah, Smudge stands for Software Mutuation Utility and Data Generation Engine. It has support for a lot of protocols. Unfortunately, it only does network fuzzing, so you can't do anything else with it. Some of the test cases it uses were taken from Spike, which is something I'll cover in the next couple of slides. So yeah, Smudge is pretty cool. Unfortunately, it's unmaintained, so it's kind of hard to, because it's got some bugs in there, so it's kind of, if you don't know it that well, it's kind of hard to work with it. But it's pretty cool though. You can find lots of cool stuff with it. For example, it broke subversion, shoutcast, some IRC daemons, a bug in mod security, and a whole range of other stuff. Right, so this is the subversion bug, which is basically you get control over several registers. And then the one where it breaks now is basically a read from an address you can control. In the bottom you can see 3F, 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 which is an address you control. And later on down that code path, you can actually write to some of the addresses you control. So this one's a pretty neat bug. Right, so that was Smudge. Yeah, okay, moving on to Spike, which is a fuzzing framework, which is written in C. It's written by Dave Eitel. It comes with a lot of default fuzzing tools for anything you can imagine. You know, the Oracle TNS listener. It's got support for lots of like remote RDP for Windows, a Gopher daemon, and a whole range of other cool things. Spike is a huge tool. It's really cool. It's what Dave Eitel called, it uses block-based fuzzing, which means that if you've got a protocol, you can split it up in several blocks and then start fuzzing from a specific block. Most people say that Spike doesn't have that many documentation. I think it actually has a fair amount of documentation. It's got some slides that Dave has, a paper, and a whole lot of fuzzing tools and fuzzing scripts in there that you can just look at and see what it does and just learn from it. Unfortunately, Spike, again, only does network fuzzing. Yeah, it kind of sucks, but, well. And there's Spike file, which is sort of like Spike. Basically, it's Spike 2.9, and it's a modification which Adam Green from iDefense made. And basically, all the network stuff got ripped out and got replaced with code to fuzz files. Which is interesting, because you get the same scripting language that Spike has, but now you can not only fuzz networks, but you can also fuzz files. So, some stuff that Spike broke. It broke a lot of stuff, you know, the list is here. The interesting thing about Spike is that, like, some of the scripts are kind of broken. Like, Dave Eitel, at least I'm guessing, probably broke them a little bit so that 0-day he found doesn't get exposed. And on his mailing list, there's a guy, Andy, who made a comment about it, saying he recommends to use Spike. You know, although it's written in C and it appears to be broken on purpose, you know, it's really cool to use and find cool bugs with it. So, right, I was actually going to do a demo of Spike with the Gopher fuzzing and show you that if you make some slight modifications, you find cool bugs in Internet Explorer. But unfortunately,